question because it's something that confuses people a little bit, okay? Now, the confusion has to do with this idea of when I take expectation of the xi's, I can treat xi's as constant, okay? When I take summations of xi's, the xi's cannot be treated as constant. So there's a little bit of confusion there, and the confusion is really coming from the terminology that we're using, okay? It's really coming from the terminology that we're using. The best way to see this is if I give you an example. Imagine that the x's that I have are x1 is equal to 2, x2 is equal to 3, x3 is equal to 10, x4 is equal to minus 2. Okay, imagine that these are your x's. Okay, if I do sum of x bar times xi, I going from 1 to n, what would this be equal to? Well, I could use things like, I could say things like x bar is, I would say things like x bar is a constant, so I can pull that out of the summation notation. Maybe the word constant is not really a good word. Maybe what I should say is x bar is non-changing term. Right? X bar doesn't change in the terms of that summation notation. So if I were to open up that summation notation, it would look like this. Because this x bar is a non-changing term in that summation notation, I can pull it out. But x bar is, of course, a constant as well. I know what x bar is. I can calculate it from here, right? From here, I can calculate what x bar is. Agree? It's actually 13 over 4, right? 13 over 4 is what my x bar is. Now, is x1 a constant? Is this x1 here a constant? Of course it is. Is x2 a constant? Yes, of course it is. I have it in there. It's right there. But I cannot treat it as a constant, as in not changing in the summation notation, so I cannot pull it out. Because this xi means that it's changing. Okay? So you really need to think about the context of things, okay? What is the context of things? If I take the expectation of this expression, then everything within that expression is a constant. It doesn't matter that there's that summation notation that's changing, but when I see it this way, everything in here is a constant. So perhaps we should be careful with the terminology here, okay? Perhaps we should be careful with the terminology. So when you don't have an I on the summation notation, I say treat it as a constant, meaning that you can pull it out of the summation notation. It actually does not mean that that thing is a constant. It can actually change. Imagine that I give you a slightly more general problem. Instead of giving you numbers, I tell you you have a sample of 4 observations, and you actually don't know those observations. Okay? Can you pull the x bar out of the summation notation? Of course you can, even though you don't know it now. It's not an actual number, right? But then if you treat the x's as if they're fixed or known, even though you cannot assign numbers onto them, the expectation of that can also be taken. Right? You can also take the expectation of things. See if I can take any follow-up questions on that. Is that clearing out a little bit more, or see if you can follow up? And is that your question, or is it something else?
Yeah, I think it's clear. My, yeah,
No, go ahead.
the only one that is also maybe of interest is the error term with an I underneath. So that's always not a constant, right?
Of course, that's a variable that I don't observe. So the question is, how about the epsilon? Epsilon with the I underneath. Well, that's a random variable. Okay? And I'm not treating it as fixed. So when I say things like, what is the expectation of this? The answer is, I don't know. Unless I make an assumption. Unless I say, well, actually, you can assume assumption 4 holds, and then you can put a 0 onto this. Okay? But generally, you won't know. Keep those questions coming. Is there any other follow-up questions on this confusion, perhaps? When is something a constant? When can I pull it out? When can I not pull it out? Yeah.
I'm not sure if I completely understood what you were explaining. I think I got it. But then why does it say in the question, assume that xi is not a variable when it can be treated as a like?
So even though the question is assume that xi is not a variable or it's fixed, even when I give you things like this, these are variables, right? They could be anything. But I can treat them as fixed because when I'm a statistician, even though I don't know what the x1, x2, x3, and x4 is going to be, once I collect the data, then those things are going to be constants. So once I have the sample, those things are going to be replaced with numbers. So even though I can do my statistical properties and all my calculations as if those were variables that I don't know, and I call them x1, x2, x3, x4, once I will have the sample, instead of the x1, x2, x3, x4, I'll actually put numbers in there. Okay, that's that a bit over there. Any follow-up questions? It's always best when you follow them up.
So
Yeah.
treating
Yeah.
xi as a variable, what would be treating xi as a constant? What would be the expectation of xi? Not
Just
bar,
xi,
not x bar.
not x bar, because it's just going to be a constant. Yeah, that's a really good question. So look at this. That's a really good question. If you treat x3 as a random variable, then when you take the expectation of x3, you should say, I have no idea what this is. I don't know what the expectation of x3 is because I'm treating it as a random variable. But if you further impose the assumption that treat the x3s or the xi's as non-random or fixed, okay, then you could say things like expectation of x3 is equal to x3 because you're taking the expectation of a constant. It's like taking the expectation of 3 or 4 or 5 or 6. So that is a good question, right? So let me repeat that again. His question was, if in the question we are not told that the xi's are fixed, then the expectation of any of these xi's would be completely unknown to us. And the answer is yes. You'd have no way of knowing it. Right? It's like saying, what will be the value of x for my third observation? What is the expected value of x for my third observation? I don't know. But if I treat the x's as fixed or known, meaning that I have the sample, I will know what the value of my third observation's x is. Right? So I'll be able to place a number onto it. And all of these statistical properties that we're talking about, and all these calculations, we're assuming that we know what that number is. Right? We're treating the x's as fixed. Excellent questions.